We stopped yesterday, or last Thursday. We were talking about controlling execution of loops, and I kind of ran through this pretty quickly. So I want to just go back over this just a little bit. There's three things in this section that we want to talk about. The first thing we want to talk about is terminating while break and continue and termination of while loops. They're the three topics. We'll start off with break. Break is a really useful function or call when you want to break out of an enclosing loop, either because some condition changed or because, well, generally it's because some condition changed or you got input that is forcing you down a different path, or sometimes you've discovered an error. So the basic form of this is something along these lines. You have, this is, if you guys remember our little block notation, right? This would be block A. This is the stuff that comes before the while loop. This would be the while loop. And generally, the break and the continue are both used with while loops, although there's really nothing to keep them from being used with for loops as well. But they're best illustrated with this kind of while loop. So here's the while loop. Here's the condition under which the while loop runs. And you can see that right now, we've set the while loop to have a condition true. So the while loop, the whole condition, the thing that evaluates to true or false, is always set to be true. So this while loop, absent some external stimulus, is always just going to execute. Every time you come back to this statement, while true is always going to be true, and you're always going to execute the body of this loop. So all this actually does is it goes through and it accumulates integers, right? Reads them one at a time, and you can make them whatever you want. And every time through the loop, it reads the integer, converts it, reads the value, the string on the input, converts it to an integer, puts it in X, compares it to 0, and if it's not 0, it adds it into this sum. So we're computing a running sum. The sum starts at 0. When we actually put in a 0, what we're going to do is this line is going to become true. We're going to execute the break line, and what's going to happen then is we're going to come out of the body of this loop, right? So this is block A before the loop. This is block C after the loop. This is block B within the loop, and we're going to leave the closest block B. So the block B that most immediately contains us. So when we hit this, there's only one while loop, right? So when we hit this break, we're going to break out of the enclosing while loop, and we'll come down and print the sum. So the way we break out is we're going to enter a 0. This should leave us with a sum of 689. We now hit the print sum, and we print 689. So break is just a way to take you out of a loop. It doesn't take you out of a program. It doesn't take you out of a subroutine, out of a function call, out of a function. But it'll take you out of an immediately enclosing loop. Right, so in this case, while true, we come down. Once we enter a 0, once the condition for termination occurs, we break, we exit the loop. Now, you never need a break. Breaks are sometimes convenient. They're never actually needed, because we could, instead of having this loop like this, we could have it, something like sum equals 0, done equals, or continue equals true. Actually, that's not a good one. We don't want to use continue. Except, why not? Except equals true. While except, right? So we're now using our variable except, or suscept. While except x equals input, we get our input the same way. And now down here we could say except equals false. And we could even put, we don't really need it, but we could even put an else clause in here, right? If you're adding 0 to something, you're not actually changing the value. So we don't actually have to have that else clause there, but we could do something like that as well, right? And this will actually run exactly the same, assuming I give it the same inputs, 689 23 minus, we'll do minus 24 this time, and 0. And this will run exactly the same and give, a slightly different answer because I use different inputs, but it will run exactly the same, right? And it's different. You come down here, you have a loop variable. It's just a Boolean. We set it to true to start going into the loop. When we hit our done condition, our end condition, we set it to false. And now when we come back up to the top of the loop, except as false, we break the loop, we come down here. So you never actually need a break. What you need to evaluate when you're using a break is, does it make the code more readable? Similarly with the conditional, or with the continue, we'll use a for loop as an example of the continue. Oh, what's my list? Do I have my list here anyplace? Yeah. Let's see. My list less than 0. So let's say my list equals so if we do this, right, I'm just going to do list range minus 1 to 20. So L is just a list that starts at minus 1. It goes all the way up to 19. And we can do L.shuffle. And all that's going to do is it's going to make this look it's just going to make this look more random. So now we have 12, 14, whatever. The minus 1 is moved well to the end of the list, or well towards the end of the list. So now if we go for item in my list, if item is less than 0, continue, otherwise print item, what we're going to see is that as long as we don't go into this if clause, right? This is, again, we're in a for loop. Within the for loop is an if clause. If we hit the continue is going to act a little bit like a break in that it's going to do something special to the list. What it's going to do, though, is instead of jumping out of the enclosing loop, right, instead of jumping out of the while or out of the for, it's going to jump back up to the top and skip anything down here. So the print item is going to be ignored, and what we're going to do is we're just going to continue past, past any negative numbers. We're just going to, come down in, hit the continue, and ignore them. So if we come through here, what we would expect to see is 12, 0, 14, all the way up to 16, and then instead of minus 1, we should print 10. And of course, I called my list L. So let's name this L instead. Oh, and by the way, I am taping this, fortunately. And again, so we come down here and we look at our list L, right? Our list L, 16 minus 1, 10. Well, here we have our 16. The minus 1 would be right in here, and the 10. So continue just skips anything beyond the continue and goes back up to the top of the most immediately enclosing loop structure. All right. Let's see. What's the last one I wanted to talk about? Termination of a while loop. We talked about while loops and for loops, and we said that while loops are more general. They can do more things, at least in Python. In other languages, their for loops are a little more powerful. You can do multiple things, but in Python, while loops are the more general one. And what the issue we have with them is that we have to be careful that they actually reach a termination criteria. And I just want to point that out a little bit. So we have two versions of the code here, right? And all this is going to do is this is going to take X, it's going to be an input number, and it's going to walk through, and until we reach 1, right, we know that the square root of 1 is 1. Until we hit 1, we're just going to calculate the square root and print out the value we get. And if we do that, well, this is going to work pretty much, hopefully, the way we want it to work, right? We come down here, we import math, we enter a number. While that number is greater than 1, we replace the number with its square root. We print it out and we flush it. And the flush is, again, just to make sure that everything comes out immediately instead of being buffered and delayed. We'll come in here, we'll put in a number. We can put in -1. That'll exit immediately. We can try running it again. Come on. Do what I want you to do, not what I tell you to do. There we go. So it does ask for a positive number. Let's do, I don't know. We use a big number. The beauty of the square root function is it decays really quickly. So even doing that, it takes us, a handful of steps to get from that really big number down to the value 1.00002 and then down to 1. Okay, so that loop has a termination. And it's pretty obvious. Well, maybe it's not obvious, but it's pretty obvious in general that we would hope that since the square root of 1 is 1, that if we're doing our math correctly, that should eventually terminate. But what happens if we're just a little bit sloppy? And instead of saying while x greater than 1, we throw in there while x greater than or equal to 1. And we do the correct syntax on that. So now we're in a position where we put in our really big number. We get down to 1, but once we get down to 1, 1 can't get any smaller because the square root of 1 is 1, and we've now entered an infinite loop. So we have to actually kill our process, hopefully kill our process. Come on, die. There we go. In order to escape that. Now this, hopefully you would see this. Maybe you wouldn't. Typing greater than or equal to is, sometimes, especially when you're looking for you have a decreasing value. Hopefully you would catch this, but sometimes you wouldn't. You have to be very careful with while loops because it's really easy to get into a state where you think your loop condition, you think you have a termination criteria that's reachable, but that termination criteria just isn't mathematically reachable, particularly in situations where you may have some round off. All right, that's what I wanted to talk about chapter 12. Let me check our. I think I saw Kristen answering in the live chat, so I'm going to go over and see if we have any questions. Nothing serious so far.
Professor Turner.
Yes.
Sid here. There's a question that did come up in chat, and I think it was answered, but it's a very good question. So if you have two loops, a while loop and a for loop, or a for loop and a while loop, or two for loops, two while loops, if there's one loop inside another and you break inside the inner loop, it will only break the innermost loop, correct?
Right. It jumps out of the most immediately. Okay, I broke this. Let me restart my kernel. Yeah, it only jumps out of the most immediately enclosing loop.
Okay.
So if we have something like for I in range 50 for j in range, I don't know, 10 if let's find the, I don't know. This is kind of the dumbest example I've ever seen in my life. I have no idea why you would want to do something like this. But basically, for every, let's say for some unknown reason, you want to take every number from 0 to 49 and you want to find exactly one number in the range 0 to 9 that divides it evenly. What this would do with this every time through, you would pick an I value. You would go through all the possible J values until you found one that worked. As soon as you found one that worked, you would print it out and then break and go on to the next. Like I said, this is about as dumb of an example as I could think of, but you put me on the spot. And I did division by 0 because that makes sense. Let's say 1, 11 then. We'll make that a little bit better. Okay. Okay, so that's absolutely useless. But you can see that since 1 divides everything, let's try this again with 2. It doesn't have to be completely stupid. Maybe it does. See, if you guys plant the questions ahead of time, then I can prepare and come up with an idea that makes sense. Otherwise, you get stuck with this. Okay, so, right. Let's get to something like 6, right? 6 is divisible by both 2 and 3. We hit the 2, but as soon as we hit the 2, we hit the break. We never go on to 3. We jump back up to the top and increment I to be 7. Now we're going to go through, we'll go through there till we hit 7. We'll break. Again, 8 is divisible by 2 and 4 and 8. As soon as we hit the 2, we hit the break and we leave it. All right, so that just is just as an illustration of doubly nested loops with a break in between. All you do is you leave this immediately enclosing for loop. If you wanted to leave the other for loop, we could do something like if I equals 37, do a break, and now we shouldn't go past 37 because now this one isn't enclosed in this for loop, right? It's enclosed in this for loop. So this break will break us out of this other for loop. So this shouldn't give us any data beyond 37. All right. Questions?
Okay, and then the same applies for continue, correct?
Same applies for continue. Yep.
Okay, and then if you asked us to ask questions beforehand, so how do we ask them beforehand before the lecture? Email?
I was joking about that, but yeah, if you email, it's hard to do things. You don't know your questions till you get to the lecture. But yeah, if you email me, I'll try to prepare something if you have a specific question, certainly. Or better yet, post it in the discussion forum, and if we can't answer it there, we'll get it up. Because right now I'm about 5 days behind on my email, and that includes having worked a significant portion of this weekend. So I have Arcos I had to get stuff done for. All right. Any other questions?